All right, so today we're going to talk about basic equations that are related to conic sections. Some of the things you already know, and I have a list of all the formulas that you should already know either from algebra, geometry, algebra 2. Right? If you need to pause the video, then go ahead and do that. But you can write all these down, and we're going to refer back to these later. So using possibly some of these formulas, we're going to apply this to some new concepts. So one of them is the angle of inclination. All right, so the angle of inclination is basically you're going to figure out what's the angle that a line makes from the positive x-axis. So I've drawn a coordinate plane. Here's just a line. And on this line, I'm going to say that it goes through the point -3, 4, just for our example. All right, so what I'm going to use this new formula, which is my slope is equal to the tangent of theta, and I'm going to prove why that works. All right, so the angle that I'm going to find is really this angle. However, I'm going to use a reference angle right here, and I'm going to create a triangle that is conveniently a right triangle. So if you look at that triangle, if this goes through point -3, 4, then this distance is -3, this distance is +4. And yeah, it's a 3, 4, 5 triangle. But we're looking for the angle, so I would look at what is the tangent. Tangent of theta is the opposite over the adjacent. Right? And so if I wanted to find my actual angle, then I would use inverse tangent. All right, so I would do inverse tangent of 4 over -3. And I would make sure that you are in degree mode. Okay, so if I do inverse tangent of 4 over -3, oops. Then I get -53.13 approximately. All right, however, that angle is actually, remember my reference angle is over here. Now it doesn't really make sense to have a negative angle. What that angle is from the positive x-axis. This is -53.13. If you remember from geometry, these are vertical angles, so this must be the same amount as that. Since we actually want to know how much the angle of inclination is from the positive x-axis to my line, I need to actually, remember a straight line is 180 degrees, I need to add 180 degrees to that. So this angle for this example is really 126.87. Okay. Oh, and by the way, the m was your slope, right? And if you look at your line, this has a slope of my rise is 4, and my run is 3. So you can go like up 4 over 3 to the left. You could also go from here. You can go down 4 and over 3. It's the same thing, right? All right, a new formula. There's two versions of this. All right, so we have the distance from a point to a line. So if I have any particular point, let's say that I want to use a line that's similar to this one, and I wanted to measure what's the distance between this random point to that line. In order to find the distance, I want the shortest distance, so I'm actually finding that amount. It has to be perpendicular to the line. Okay, so this point would be some point at x0, y0. And then this line, if it's written in slope-intercept form, it's y equals mx plus b. If the line is written in standard form, then it's ax plus by plus c equals 0. All right, so you'll use a different formula depending on what you're given. Now, if you're given y equals mx plus b, and you'd rather use this formula, then just transform it so that everything's on the left side. It's equal to 0, and then you have an a, b, and a c value that you can plug into that formula. All right, so we're going to do some examples from your book, and if you have your book, that would be good to take out, because we'll read the directions to that. All right, so if you need to go back, you could pause the video, or you could refer back to your formula sheet as we do these problems. All right, so if you look at page 823, we're going to do number 2 first. All right, so number 2 says that it wants you to find an equation of a line that passes through the point 2, -4, and it's parallel to the line 3x minus y equals 1. They want you to find the equation in the form y equals mx plus b. All right, so a couple of things. If I know that 2 lines are parallel, what do I really know about those 2 lines? So this is something from geometry, or probably algebra actually. All right, so parallel lines, they have the same slope, right? Which means we need to figure out, well, what's the slope of that line? So I'm going to solve for y first. So really I've got negative y equals negative 3x plus 1. So y equals 3x minus 1. So the slope of this line is 3, and if my line is parallel to it, then that also has to have a slope of 3. Okay, so I know this is going to be my slope. And if it goes through this point, I'm going to use point slope equation, all right, which is this formula here. Okay, so y minus y1 equals m times x minus x1. And I'm going to do y plus 4 because I'm going to do y minus -4. And my slope is 3, and I've got x minus 2. All right, so if I solve for y equals, then my final answer is y equals 3x minus 10. All right, next problem. We've got number 7. It says, find the x and y intercepts of the circle with center 1, 0 and a radius of radius of 5. All right, so if I want to know what is my equation of that circle, it probably would be helpful, right? So my equation of a circle is this formula. I need to know the center, so I'm going to put in h and k, right? That's my 1, 0, and my radius is 5, so I'm going to square that. So I have x minus 1 squared plus y minus 0 squared equals 5 squared. Now if I simplify that a little bit, I have x minus 1 squared plus y squared equals 25. All right, so now it wants you to find the x-intercept and the y-intercept. All right, so let's maybe start with the x-intercept. So what do I remember about x-intercepts? Well, x-intercepts are always some number, comma 0. Okay, so if I know that it's going to be some number, comma 0, I'm going to put that into this formula. Here's my equation of the circle. So I'm going to do, I don't know x, minus 1 squared plus 0 squared equals 25. And now I just need to solve. So what we could do, we could complete the square. No, we could take the square root. That's what I mean to say. If I take the square root, I get x minus 1 equals plus or minus 5. So I get either 1 plus 5 or 1 minus 5, which means I get 6 or -4. All right, so that's I have 2 x-intercepts. So one x-intercept is at 6, and the other one is at -4. All right, so maybe a diagram would help for this. If my center is at 1, 0, and I have a radius of 5, all right, so here's my circle. Hopefully it looks kind of like a circle. And we can double check, right? Our x-intercepts are at 1, 2, 3, 4, 5, 6, and -4. All right, so we must have done something right. And my y-intercepts, now those are, I guess we didn't really have to go through that. We could have drawn it out. My y-intercepts are going to be here and here. So we'll have to figure out where those are. All right, so now we're going to do the same thing. What do you know about y-intercepts? Y-intercepts have some number, for my y, but my x is always going to be 0. So I'm just going to take that and put it into my equation. All right, so we've got 0 minus 1 squared plus y squared equals 25. And if I simplify, I get 1 plus y squared equals 25. And y squared equals 24. So y equals plus or minus the square root of 24. Or in other words, plus or minus 2 root 6. All right, so my y-intercepts are 2 root 6 and negative 2 root 6. And if we figure out what those are as a decimal, right, that's about 4.89 and 1, 2, 3, 4, 5, so just a little under 5, so that matches up and makes sense with our diagram. All right, next question, number 18. All right, so number 18 says that they want you to find the distance from the point to the line using each of the two formulas that they give you. So the point is -2, -3, and the line that they give you is y equals -4x plus 1. All right, so for part A, they want you to use the first formula, which is this one. Okay, so we've got d equals m times x sub 0 plus b minus y sub 0 over the absolute value of all that over the square root of 1 plus m squared. All right, so here's my x sub 0, here's my y sub 0, here's my m, here's my b. All right, so all we're doing is substituting our numbers in, which this should be pretty easy since it's already in y equals mx plus b form. So we have -4 times -2 plus 1 minus -3, the absolute value of all that, and we have the square root of 1 plus -4 squared. So my denominator, I get square root of 17, and this is 8 plus 1 plus 3, which is 9 plus 3, which is 12. Okay, so that's good. If you want to rationalize it, you could do that as well. All right, part B, they want you to use the other formula. Now, I would not recommend using this formula for this problem. I think this is just kind of extra work. However, I need to rewrite that. So I would need to write that as 4x plus y minus 1 equals 0. And then I've got my a, b, and c. So here's a, here's b, here's c, and now you're just going to substitute your numbers in. So my distance is equal to the absolute value of 4 times -2 plus 1 times -3 plus -1. All over. This time I need to do a squared plus b squared, so 4 squared plus 1 squared. All right, so that's also root 17. And over here we've got -8 minus 3, that's -11, minus 1 is -12. Oh, but it's absolute value. There we go. Makes sense. All right, so 12 over root 17. So as you can see, you get the same answer no matter which equation you use. All right, new problem. We're going to do number 21, just part A only. All right, so number 21 says, find the equation of the circle that has a center at 1, 3, and it's, no, I'm looking at the wrong one, -2, -3. And it's tangent to the line 2x plus 3y equals 6. All right, so I think it would be helpful to draw out a diagram and figure out what this even means. All right, so we know for sure that, well, I know it's got to fit x minus -2, so x plus 2 squared, plus y minus -3, which is y plus 3 squared, equals r squared. So really the question is, how big is the radius, right? All right, so let's draw out a picture. We've got a center at -2, -3, and some circle, we don't know how big it is, but it's tangent to this line. So if it's 2x plus 3y equals 6, I know this would have an x-intercept at 3 and a y-intercept at 2. So here's my line. And if it's tangent to it, then I need to know, here's my radius, right? So hopefully this diagram looks okay. All right, so there's your picture. There you got a circle. It's tangent means it touches the line in one location, right? And really, what am I trying to find? The radius, which is also known as the distance between this point and the line. So you're using the same exact formula we used in 18. Now, you could either solve for y and do the y equals mx plus b formula, or you could move the 6 over. That's probably easier, right? We'll just use 2x plus 3y minus 6 equals 0, and then I'm going to use the bottom formula. So here's my a, my b, my c, my x sub 0, and my y sub 0. And then all I'm going to do is find my radius, which is also known as my distance, and I'm just going to substitute in the numbers. So 2 times negative 2 plus 3 times negative 3 plus negative 6. I'm going to do the absolute value of all of that, all over the square root of a squared plus b squared, which is 2 squared plus 3 squared. All right, so when I simplify, 4 plus 9 is square root of 13. And this is negative 4, negative 9, that's negative 13, negative 6, that's negative 19. The absolute value of that is 19 over root 13. All right, so there's my distance, otherwise known as my radius. And to answer the question, it's what is the equation of the circle? So my equation, I had already set it up. But now I need my radius squared. So if I square this, this will give me 361 over 13. Right? 19 squared is 361, and root 13 squared is just 13. All right, 2 more problems, and then we're all done. So number 25 and 26. All right, number 25 says, from the point 0, negative 5, tangent lines are drawn to the circle x minus 3 squared plus y squared equals 4. Find the slope of each tangent. All right, so maybe draw another picture to help you see what's going on here. So what do we know about the circle? Well, we know that the center is at 3, 0, and my radius equals 2. Make sure you remember this is radius squared, so my radius is 2, not 4. All right, so I have a circle at 3, 0, and I'm going to go up 2, down 2, left 2, and right 2. All right. Okay, so here's my circle. It says from the point 0, negative 5, which is down here, tangent lines are drawn. So a tangent means that it's going to cross my circle in 2 places. Well, actually, it's going to touch it in 1 place, but there's 2 tangent lines. So I can have a tangent down here, right? It's a line, so I guess it goes on forever. And another one over here. All right, so I need to find the slope of those lines. So what exactly do I need to find? Well, I think it would be helpful to find this line. I know it has some slope. I know the y-intercept is negative 5. Okay, so that is my y equals mx plus b. What else do I know? I know that the distance from the center to this line is my radius. So if my radius is 2, then I know that the distance is also equal to 2. All right, so there's some information there. So that's leaning towards this equation. Okay, so let's just write down the equation and fill in as much of it as possible and see what we have to find. So you're finding slope, remember, because we don't know the m. All right, so we know the distance is 2. We don't know the slope. We know that the point it goes through is 3, 0, right? So there's 3. I was trying to make sure we weren't using this point, so this is 3, 0. Plus my b is negative 5, And right, we're using, this is my x sub 0, y sub 0. All right, so that's everything I know, and I'm going to take the absolute value of all of that, take the square root of 1 plus m squared. All right, so it's different because we have to solve for m, right? Okay, so I'm going to multiply, so I have 2 times square root of 1 plus m squared, and this becomes 3m minus 5, the absolute value of 3m minus 5. All right, so I think the easiest way to get rid of something, if you just saw a square root, if you wanted to get rid of it, you would square it. And if you wanted to simplify something that's an absolute value, you could also square it as well. So let's just square everything, and that should hopefully simplify this whole problem. So I have 2 squared, that's 4. And if I square a radical, it's just going to be 1 plus m squared. So this will become 4 plus 4m squared. And over here, if I square this, make sure you FOIL. So I have 9m squared minus 30m plus 25. All right, so now you can see we have a quadratic, and the easiest way to solve this would be to move everything to probably the right side. And if I subtract 4, I get 21. And I'm just going to use a quadratic formula program. All right, so A, B, and C, we've got 5, negative 30, and 21. All right, and I'm going to do a radical. So I have m is equal to 15 plus or minus 2 root 30 over 5. And there are 2 answers, because remember there were 2 tangent lines. Right? This one has the positive slope. This one also is positive. If you needed to see it as a decimal, right, we could do 5, negative 30, and 21, and choose decimal this time. Right? So this one has a slope of 5. That's the steeper line. This one has a slope of 0.8, the less steep line. All right, one more problem, and then we are all done. All right, the last thing is they want you to find the distance between the 2 parallel lines, y equals 2x minus 1 and y equals 2x plus 4. I'll give you a hint. The answer is not 5. Right? It's not just the difference between 4 and negative 1. All right, it says, hint, draw a sketch and then find the distance from the origin to each line. All right, so 2x minus 1 would start at negative 1. It would go up 2 and over 1. All right, so there's line 1. And line 2 would have the same slope, but it would go over here. All right, so it says find the distance between the origin and each line. So that's an easy thing. We're going to find this distance, and we're going to find this little tiny distance. All right, so origin's obviously 0, 0. So let's just start with this one. If I want to know the distance to y equals 2x minus 1, I'm going to use d equals, and I'm just going to use the y equals mx plus b version of the formula. So 2 times 0 plus negative 1 minus 0, and then all over square root of 1 plus 2 squared. All right, so that gives me 0 minus 1. So absolute value of negative 1 is 1 over root 5. All right, so that's the distance. That's that tiny distance there. And then this one, we've got y equals 2x plus 4. I'll zoom in a little bit. All right, so I want to use the distance equals 2 times 0 plus 4 this time, minus 0, over 1 plus 2 squared, square root of that. All right, so we've got 0 plus 4, that's 4. Absolute value of 4 is 4, equal or over root 5. All right, so distance 1 and distance 2, and I want to add the 2 distances together, so I've got 1 over root 5 plus 4 over root 5, which is 5 over root 5. And you can rationalize that if you want, or you could just leave it like that. Sorry, zoomed in too much there. All right, and then I think we're all done. So this should cover everything for days 1 and 2. And after this, we'll get into conic sections.